Here we have pre-example number 3, and this aligns with factoring method number 3. Factoring method number 3 was the sum and or difference of two cubes. You may not see where that name comes from just yet, but hopefully it makes sense when we're done. When you distribute a binomial by a trinomial, you have 2 things times 3 things. You should get 6 things. We're going to start with 4x and multiply it by all 3 terms over here. 4 times 16 is 64. You need to know these by heart. X times x squared is x to the third. You also need to be very sharp with your properties of exponents. 4x times negative 20x, negative 80x squared. 4x times positive 25 is plus 100x. Now we'll multiply 5 times all 3 terms. 5 times 16 is 80. The fast way to multiply a number by 5 is to multiply the number by 10 instead, and then divide by 2. Because 10 divided by 2 is 5, this will get you the same answer. 16 times 10 is 160, and 160 divided by 2 is 80. You're welcome. So this is going to give us 80x squared. Instead of writing it over here and then needing to pay attention to what needs to combine or creating a very long expression, I'm going to go ahead and write plus 80x squared underneath my other x squared term. Your x squared terms are called your quadratic terms. 5 times negative 20x. That would be negative 100x, and again, I won't write it here, I'll put it underneath my other x term. Your x term is known as your linear term. Positive 5 times positive 25. That's positive 125. I didn't have another term like this, or constant term, so I wrote it in its own column. By stacking like terms vertically, it helps us not miss anything and stay more organized. What I end up with is 64 x to the third plus 125. This right here is the sum, the result of the addition operation, of 2 cubes. What are cubes? Cubes are the result of something being raised to the third power. I want you to think of this thing I just drew right here, and I'm going to trace over it and really make it bold. I want you to think of this right over here. These are glasses. So imagine these are someone's glasses, and when they put them on, they have X-ray vision, and they can see what it was that created 64, x to the third, 125. What was being raised to the third power that caused that to be the result? So if you had X-ray vision and you were able to see what it was that created this expression, 64x to the third, that goes in this lens and that goes in this lens. Really, these are just parentheses cubed with a plus sign in between because that's a plus sign, so that's plus. What is being cubed to make 64x to the third? Again, these are on that list of math facts I told you that you should memorize. What to the third power is 64? 4. What to the third power is x to the third? X. What is being cubed to give us 125? 5. 4x to the third plus 5 to the third. This is equivalent to this, and both of these are equivalent to this. This is factored form. Factored form usually seems pretty neat and tidy. In this case, factored form is a little chunky and intense. These are a little bit more neat and tidy. These are actually in expanded form. Once you get the sum or difference of cubes into this glasses looking form over here, there is a quick trick to getting it factored. It's actually a bit easier to memorize and get correct than factoring by grouping. Let's see how to factor on example 6. Here, instead of the sum, we have the difference of two cubes, but still the same idea. First thing I'm going to do is draw a set of cubing vision glasses. What's being cubed to make 125? X to the third power. 5x. And what's being cubed to make 27? 3. Once you have this set up, we're going to refer to this as we factor. Next, what you're going to do is you're going to draw a smaller set of parentheses. This is for your binomial, and a larger set of parentheses. This is for your trinomial. Binomial, trinomial. Next, there is a longer, more formal way to show you this, but if you trust me, I promise you'll always do really well and get these right every single time with this magical factoring trick. Trust me? Let's go. First thing we're going to do, again, please trust me, is we're going to take these little 3's up in the exponents. We're just going to put those in our pocket. We're going to save them for later. We're going to use them. They'll be a little magic dust. But we're going to take those 3's and we're putting them in our pocket. So what's left if we took those 3's? This little exponent and that little exponent? All we're left with is 5x minus 3. And that goes right in there. Now remember those 3's that we just put in our pocket, those purple 3's? All right, we're going to sprinkle some fairy dust time. Ready? What is 5x times 5x? So I have 3 specks of fairy dust on this side and I'll have 3 specks out of the other pocket. What's 5x times 5x? 5 times x times 5 times x is 25 x to the second. What is 5x, that's my third speck of fairy dust from my left pocket, times, go into my right pocket, 3. What's 5x times 3? Just ignore that sign, okay? 5x times 3 is 15x. I have 2 more specks of fairy dust in my right pocket. What's 3 times 3? 3 times 3 is 9. Now, fairy dust. Fairy dust is basically like glitter. And you know how glitter is. Once you touch it, it's like you can't get it off. It's everywhere. It's just stuck on you. It's all over your face. It's getting on everything. So what are we going to do about the glitter? We're going to need to wash our hands. Guys, trust me, okay? I promise. So if we need to wash our hands to get rid of this fairy dust that's all over our hands, this magic dust, then we're going to wash our hands with soap. What the heck am I talking about? Well, soap is another mnemonic device. It stands for same sign as the original problem, opposite sign of the original problem, always plus. And that one's just always plus. This is done. It's factored. That whole thing up there is your answer. Trust me. If you follow my cubing glasses fairy dust soap method, you'll always, always, always get these right. Let's try the next one. This next example, however, has a little bit of an extra step. There's actually a greatest common factor I need to take out first. If you remember, after I wrote down those 5 methods, I said that you need to be able to do any combination of these methods. I'm not kidding, okay? What's the greatest common factor you can think of between 24 and 3,000? The greatest common factor is 3. 3. So that means I'll divide both of these terms by 3, and I'll multiply out in front by 3, and that's how a 3 will get out front. Three will just hang out right there. Pretzel to reduce, invisible pretzel this time. 8 x to the third plus 1,000. Sorry, the 1,000's kind of climbing into that 3. Now, this 3 is a GCF and it sits out front. Here, I have a sneaky sum of 2 cubes. Cubing glasses. What's being cubed to make 8x to the third? What do I see with my cubing vision glasses? I see 2x. 2 times 2 times 2, x times x times x. What's being cubed to make 1,000? 10. This tells me I could have probably factored out something bigger. However, even if you can, you'll just be able to factor it out at the end. And that's okay, but if we had made the prime factorization tree, we definitely wouldn't have left anyone behind, and we really would have gotten out the greatest common factor. That means 3 is not the greatest common factor, it's just a common factor. Carrying on, 3 is still out front, a smaller set of parentheses and a larger set of parentheses. Take the 3's, put them in my pocket. What's left over here? 2x plus 10. Fairy dust time. 2x times 2x. 4x squared. 2x times 10. 20x. 10 times 10. 100. Fairy dust, 3 specks from each pocket. But gotta wash my hands with that good old soap. Same, opposite, always plus. Now, we could factor it a smidge further. I could take a 2 out of this. And what can I take out of this? I could take out a 4. Take out a 2. Take out a 4. Multiply out here by 2. And 4. What will we get for our answer? 3 times 2 is 6 times 4 is 24. 24 could have been my greatest common factor. Pretzel in your head, reduce this guy. Make sure you reduce the 2 with the 2x and the 10. Reduce the 4 with all 3 terms. This would be more of like that peacock I was telling you about. X squared minus 5x plus 25. And that, ladies and gentlemen, is the answer to example 7. I know that this quadratic is going to look factorable, but I promise you that these are not factorable quadratics. If they were factorable, it would have been a part of the whole entire package of the cubing vision, magic dust, soap method. Since I never mentioned it, it's because you are done. You cannot go any further. Let's try example 8. What's the greatest common factor right there? X to the third. Here we have our first minus sign. Usually they're plus signs. If you don't put a minus sign here, it's all going to come crumbling down. It's important that whatever sign is here is in my greatest common factor underneath this line right here. 343 is my greatest common factor. Bring it out front. Bring this out front. Again, don't forget your plus or minus sign from that bottom number. When you do this pretzel, pay attention to the signs. 2x to the fourth divided by x to the third is 2x minus x to the third divided by x to the third is 1. Negative 686x divided by negative 343. That's also 2x. Positive 343 divided by negative 343 is negative 1. If you didn't put that negative there, you would have gotten a positive 1 and you would have been all messed up. If these don't match, it's not factorable or you messed up. If these don't match, it's not factorable or you messed up. Since they match, 2x minus 1 is a greatest common factor. I take it out. What's left inside? X to the third minus 343. This number should look familiar to you if you've been practicing that list of math facts I told you about. 2x minus 1 can just stay the way it is. Let's put on our cubing vision glasses. What's being cubed to make x cubed? X. What's being cubed to make 343? 7. A way I used to remember is I would say to myself that 3 plus 4 is 7 to the third. I know, it's weird, but maybe it'll help some of you. Dropping down that 2x minus 1 since I don't want to lose it. Then I have a smaller set of parentheses and a bigger one. Take those 3's, put them in my pocket. What's left? X minus 7. Now sprinkle that magic dust. X times x, x squared, x times 7, 7x, you ignore the sign. 7 times 7, see, 3 sparkles on each from my magic dust from the 3's and 3's. 7 times 7, 49. Wash off that excess fairy dust. Same, opposite, always plus. Same, opposite, always plus. That's it. That's your answer. We factored that big polynomial expression, and here we got our factored form. One more example for this set. What's the greatest common factor between these first two terms? X to the third. Here, definitely got our plus sign. Just 8. Bring that x to the third out front, because we're going to divide it out right there. Bring that 8 out front. We're going to divide that out right there as well. But when you divide, you multiply to keep things balanced. Using our pretzel, what's left inside? X to the third plus 1. X to the third plus 1. If it matches, it's factorable. If not, it's not factorable or you made a mistake. Bring that out front. What's left inside? Now, what do we got here? We actually have two sums of cubes. So what does this mean we have to do? Well, we have to put on our cubing vision glasses, our orange pair and our green pair. But remember, we really should have parentheses separating these because they still represent the orange and green. What's being cubed to make each of these four terms? X, 1, X, and 2. Then a smaller, a larger, a smaller, and a larger. Take the 3's, put them in our pockets, put that little guy in the first parenthesis, x times x, x times 1, 1 times 1, x times x, x times 2, 2 times 2. Time for the soap. Same, opposite, always plus, same, opposite, always plus. These get increasingly more and more involved, and they show up in more and more topics. Next, we're going to look at the difference of two squares, and then the only one we have left is the AC method and grouping. While that's really a combination of two methods, it's really important, so I listed it on its own. I hope you found this section of the 5-part factoring series helpful. If you feel like you've mastered this type of factoring, be sure to give the video a thumbs up for your records. However, if you have not mastered this type of factoring yet, give this video a thumbs down so you remember that this is a video that probably deserves more of your attention. I won't be offended, I promise. It's to help you remember what you need to practice and maybe to take out a little bit of steam on the lesson video that maybe frustrated you a little bit, but eventually you'll be able to come back and give it a thumbs up and show the video who's boss. Have a great day.